determine the appropriate breaker size for a set of air conditioners, several calculations must be performed. Firstly, calculate the current draw per air conditioner. Given that each air conditioner consumes 2500 watts at 208 volts, the current can be found by dividing the power by the voltage. 2500 watts divided by 208 volts equals approximately 12 amps per air conditioner. Secondly, calculate the total current draw for all 13 air conditioners. This is done by multiplying the current draw of a single unit by the total number of units. 12 amps per unit multiplied by 13 units equals 156 amps. Understanding breaker sizing is critical for safety and code compliance. The general rule is to size the breaker at 125% of the maximum continuous current. This accounts for the continuous operation of equipment like air conditioners, which can run for extended periods. In this scenario, the continuous current is 156 amps. Multiply 156 amps by 1.25, which equals 195 amps. Therefore, a 200 amp breaker would be appropriate. Check the existing panel capacity. The existing panel is rated for 200 amps. With the air conditioners drawing a total of 156 amps, there is a remaining capacity of 44 amps. This suggests that the panel should be adequate to handle the load. However, these calculations are preliminary and a qualified electrician should confirm them. They will consider factors such as wire size, voltage drop, and local electrical codes. Ensuring the correct wire size is essential to prevent overheating and potential fire hazards. Voltage drop must be within acceptable limits to maintain the efficient operation of the equipment. An electrician will perform a comprehensive load calculation to verify the suitability of the panel and breakers. For single-phase loads, the 125% rule ensures that the breaker can handle continuous operation without nuisance tripping. The total current draw is a key factor in determining the appropriate breaker size. While the initial calculations suggest the existing panel has sufficient capacity, a professional assessment is necessary. Factors to consider include the ambient temperature, the type of wiring, and any other loads on the panel. In summary, calculate the current per air conditioner, then calculate the total current. Apply the 125% rule to determine the breaker size and verify the panel capacity. Finally, always consult a qualified electrician to ensure all calculations and installations meet safety standards and local codes. Consider that electrical panels and breakers have specific ratings and limitations. Overloading a panel can result in overheating, damage, or even fire. It is essential to distribute the load appropriately and avoid exceeding the panel's rated capacity. Wire size is determined by the ampacity of the conductors, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. The National Electrical Code, known as NEC, provides tables that specify the allowable ampacities for different wire sizes and insulation types. Using undersized wires can lead to voltage drop, reduced efficiency, and potential hazards. Voltage drop is the reduction in voltage along a conductor due to its impedance. Excessive voltage drop can cause equipment to operate inefficiently or fail prematurely. It is important to minimize voltage drop by using appropriately sized wires and keeping conductor lengths as short as possible. A load calculation is a comprehensive assessment of the total electrical load on a panel or service. It takes into account all connected loads, including lighting, appliances, and equipment. The load calculation helps determine the required panel size, breaker sizes, and wire sizes. Always consult with a qualified electrician to ensure that electrical installations meet safety standards and local codes. Electricians have the knowledge, skills, and experience to perform load calculations, select appropriate equipment, and install wiring systems safely and correctly. Understanding electrical concepts like current, voltage, power, and resistance is crucial for safe and efficient electrical installations. Current is the flow of electrical charge measured in amps. Voltage is the electrical potential difference measured in volts. Power is the rate at which electrical energy is transferred, measured in watts. Resistance is the opposition to the flow of current, measured in ohms. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This relationship is fundamental to understanding electrical circuits and calculations. Power equals voltage times current, or watts equals volts times amps. This formula is used to calculate the power consumption of electrical devices. When sizing breakers and conductors, it is important to consider the continuous load. Continuous load is a load that operates for 3 hours or more at a time. The NEC requires that breakers and conductors be sized at 125% of the continuous load. This ensures that the electrical system can handle the continuous load without overheating or tripping the breaker. Short circuit protection is another important aspect of electrical safety. A short circuit occurs when there is an unintended low resistance path for current to flow. Short circuits can cause very high currents to flow, which can damage equipment and cause fires. Circuit breakers and fuses are used to protect against short circuits by interrupting the current flow when a short circuit occurs. Ground fault protection is also important for electrical safety. A ground fault occurs when there is an unintended path for current to flow to ground. Ground faults can cause electric shock hazards. Ground fault circuit interrupters, known as GFCIs, are used to protect against ground faults by interrupting the current flow when a ground fault occurs. Electrical safety is paramount when working with electrical systems. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow all applicable electrical codes and standards. If you are not qualified to work on electrical systems, hire a licensed electrician. Proper grounding is essential for electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to protect against electric shock hazards. All electrical equipment should be properly grounded. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground. Bonding helps to reduce the risk of electric shock hazards and ensures that ground fault protection devices will operate properly. Surge protection is used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, power outages, or other electrical disturbances. Surge protective devices, known as SPD, are used to divert surge current away from sensitive equipment. Electrical inspections are conducted to ensure that electrical installations meet safety standards and local codes. Electrical inspectors check for compliance with NEC and other applicable regulations. Passing an electrical inspection is required before an electrical installation can be energized. Always use approved electrical equipment. Approved equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Using unapproved equipment can be hazardous and may violate electrical codes. Maintain electrical equipment in good working order. Regularly inspect electrical equipment for damage or wear. Replace damaged or worn equipment promptly. Keep electrical equipment clean and free of dust and debris. Avoid overloading electrical circuits. Overloading a circuit can cause the breaker to trip or the fuse to blow. It can also overheat the wiring and create a fire hazard. Use extension cords safely. Do not overload extension cords. Use extension cords that are rated for the amperage of the equipment being used. Inspect extension cords for damage before each use. Do not run extension cords under rugs or furniture. Be aware of the potential hazards of electricity. Electricity can be dangerous if not handled properly. Follow all safety precautions when working with electrical systems. When performing electrical work, it is crucial to adhere to the National Electrical Code, known as NEC guidelines. The NEC provides comprehensive standards for electrical installations to ensure safety and prevent hazards. Understanding and following these guidelines is essential for any electrical project. One key aspect of electrical work is proper grounding. Grounding creates a safe path for electricity to flow in the event of a fault, preventing electric shock. Ensure all electrical systems are properly grounded according to NEC standards. Another important consideration is overcurrent protection. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. Selecting the correct size breaker or fuse is critical for safety. The NEC provides guidelines for determining the appropriate overcurrent protection for different types of circuits. Wiring methods are also crucial for safe electrical installations. The NEC specifies the types of wiring allowed in different situations. Use the appropriate wiring method for the application to prevent damage and ensure safety. Conductor sizing is another critical aspect of electrical work. The NEC provides tables that specify the allowable ampacities for different wire sizes. Selecting the correct wire size is essential to prevent overheating and voltage drop. Box fill calculations are necessary to ensure that electrical boxes are not overcrowded with wires. Overcrowded boxes can lead to overheating and potential hazards. The NEC provides guidelines for calculating box fill. Device boxes, junction boxes, and pull boxes are a few examples. Understanding these calculations is important for safe electrical installations. Working space around electrical equipment is essential for safety and maintenance. The NEC specifies the required working space around electrical panels and other equipment. Ensure that there is adequate working space to allow for safe access and maintenance. Arc flash hazards are a serious concern in electrical work. An arc flash is a dangerous electrical explosion that can cause severe burns and injuries. The NEC requires that electrical workers wear appropriate personal protective equipment, known as PPE, when working on energized equipment. Electrical safety training is essential for anyone working with electrical systems. Training should cover topics such as grounding, overcurrent protection, wiring methods, conductor sizing, and arc flash hazards. Never attempt electrical work unless you are properly trained and qualified. Always follow lockout/tagout procedures when working on electrical equipment. Lockout/tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair. Use appropriate test equipment to verify that circuits are de-energized before working on them. Test equipment should be calibrated and in good working order. Inspect electrical tools and equipment regularly for damage. Replace damaged tools and equipment promptly. Use only approved electrical materials and equipment. Approved materials and equipment have been tested and certified by a recognized testing laboratory. Avoid using counterfeit or substandard electrical products. Follow manufacturer's instructions when installing electrical equipment. Improper installation can lead to safety hazards and equipment failure. Be aware of the potential hazards of working with electricity. Electricity can be dangerous if not handled properly. Always follow safety precautions when working with electrical systems. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Do not attempt to perform electrical work that you are not comfortable with or qualified to do. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for specific recommendations and to ensure that all electrical work meets safety standards and local codes. An electrician should be consulted to make sure all codes are adhered to and followed.